everyone. Welcome back to MakerFun, powered by Brilliant Labs. I'm Nellie, and I'm so glad you could be here with us today. This week, we'll make waves in a jar, build a fully functional weather station, do a cool, colorful science experiment, talk with a real meteorologist, and use the water cycle to make salty water safe to drink, although it may take a few days. And now over to our special correspondents out in the woods.
Why do clouds change shape and size?
Very interesting question. Clouds change shape and size because clouds are part of the atmosphere, and the atmosphere is always in motion and is always changing. Just like wind that we experience here on the ground, there is also wind blowing high up in the atmosphere, and that wind pushes and pulls on clouds and changes their shape and size. Even though it seems a bit strange, the atmosphere is actually a fluid, just like the ocean, except the atmosphere is much, much lighter than the ocean. But you can think of the atmosphere, including the air around us here on the ground, as being kind of like an invisible, lightweight ocean. Clouds form by condensation of water vapor in the atmosphere, kind of like when you see your own breath on a cold window pane. Clouds disappear because of evaporation, kind of like when the window pane becomes clear again. So condensation and evaporation also continuously affect the shape and size of clouds.
Does pollution affect weather?
Wow, great question. So air pollution can actually affect the weather in different ways depending on what type of pollution it is and also how much pollution there is. Sometimes if we burn too many fossil fuels like oil, gas, and coal in the same place, that pollution can combine with water in the atmosphere and create acid rain. Also, volcanic eruptions and forest fires can sometimes cause thunderstorms to happen because there's a lot of heat and it causes the air in the atmosphere to rise upward in a process called convection, which can sometimes lead to thunderstorms. Over longer periods of time, pollution from greenhouse gases like carbon dioxide and methane can cause the average temperature of the atmosphere to increase by trapping heat, kind of like an invisible blanket. Maybe you've heard of this before. It's called global warming, which leads to climate change.
What tools do meteorologists use to predict the weather? It's really cool.
Tools. Well, unfortunately, meteorologists are not able to rely on tools like this, but we do try to use as many different tools as possible when predicting the weather. We look at weather observations from different places, which are given by trained people on the ground, because maybe the weather that's happening in one place will happen at a different place a little bit later, depending on which way it's moving. We also look at pictures taken by weather satellites located in outer space that show clouds and also show how the atmosphere is changing over time on a very large scale. Meteorologists also look at information from weather radars, which are located on the ground and detect precipitation like rain and snow and show how it is moving over time and also how it might be developing or dissipating over time. Another tool that we use in predicting the weather is something called climatological data, which is information about a certain place for a certain time of year that tells us what the average condition might be for that place for that time of year based on information from years in the past. I would say that the most important tool that meteorologists use in predicting the weather, especially when the forecast is for several days into the future, is something called numerical model data. This is information provided by a computer that tries to predict what the atmosphere will be doing in the future, and this is based on science called fluid dynamics and thermodynamics, and this computer data also combines this science with real observations that have been given.
Hello everybody and welcome to another MakerFun activity. I'm Sarah and this is Lennon.
Hi everybody.
Today we're really excited because we're going to be studying the weather behind wave energy on the ocean and even making our own ocean in a jar so that we can see that energy in motion. Maybe you've been at the ocean before looking far out and seeing little black dots out there bobbing on the waves, and they're actually birds and they move along with the ocean waves no matter how big or small they are.
Did you know that the free seabirds in Atlantic Canada is a laughing gull, great cormorant, and a black duck?
A laughing gull, is that anything like a real seagull or a seagull that we see on a regular basis?
No.
What, did you tell really good jokes? On windy days during stormy weather, the wind moves over top of the ocean. With the calm water on top, it pushes down on the water underneath, creating water to be forced out and to create the peak or a crest of a wave. And then we have these magnificent waves, either big or small. For today's project, we're going to be using materials from around home. We're going to need a glass jar or a plastic jar.
And you're definitely going to need a top on it because you're going to have liquids in it tipped on the side. And these periwinkles are optional.
For decoration, to give it that little ocean effect.
You're going to need some baby oil or food oil.
Food oil, cooking oil. And then to color our water.
And we're also going to need blue food coloring.
Awesome. So let's get started. So for the first step, Lennon's going to go ahead and add our water to our jar. We don't want to fill it up to be half water and half oil. We want to have more water than oil, so you can look at it. A good way to tell is that in science, if we have a flat surface, my hand's not flat, we can look down and we can see that this is pretty much halfway. So we know that we want to add a little bit more water to have how many? So we still need to add a bit more water so that it's 2/3 of the way filled with water, which means that if you broke the jar up into 3 sections, 2 of those 3 sections would be water. So we still need to add a little bit more because the point of this is after we add our oil, we don't want to have much air in the bottle. Lennon's going to go ahead and add a few drops, that's good, a few drops of food coloring, and if you don't have a spoon to mix it, you can just gently swirl it. That's a nice, beautiful jar of water. So what are we going to do next, Lennon?
Pour the oil in. As you see, the oil's floating on the water.
Floating on the top of the water. Yes, that's because of density. Density means that it's how much stuff is in a certain area, and the oil is certainly less dense than the water. You're going to put your periwinkles in. I think we could use a little bit more water because we really don't want to have any airspace at the top of the jug. So before you put the jar top on there, fill it up with water until it's almost up to the top. This is really important, friends, because we don't want to have any room for air to, there's going to be some air in there, but we really want to have it mainly oil and water for that effect. That's perfect. So why don't you go ahead and put the top on. Tight. We really want to make sure it's tight because we have oil and water in there. So as you swirl it gently, rock it side to side to mimic the ocean energy, side to side, and you can see where the oil sits on top of the water. You can see the movement of the waves. Now this isn't exactly the same as how a real ocean works, but because the oil is less dense, lighter, and sitting on top of the water, it creates the same effect that air would in an ocean. And we can see here, we move it side to side. Side to side, it's got that really nice ocean effect, and it's got the periwinkles at the bottom. And again, if you don't have periwinkles, that's okay, but I think that imagine adding some sand. We really had fun making this project at home, and we hope that you did too. Maybe you could share what you made on one of our social networks, or you can take a picture and mail it to us in the mail. So thanks again for joining us, and we always want you to stay brilliant. Stay brilliant! Thanks again. See you soon.
Thanks, Lennon and Sarah. Now I'm going to need to find some jars to clean out. Did you know you can build your own weather station? Lauren's going to show us how to do it with only stuff you probably have already in your house.
Hi everyone, my name is Lauren, and today we're going to be making a weather station. So with this weather station, you're going to be able to measure changes in temperature, wind speed, and rainfall. So we're going to be making a thermometer, an anemometer, and a rain gauge. So I'm going to start off with showing you how to make a thermometer. What you're going to need for this is a clear bottle that can be plastic or glass, water, and something to measure the liquid with, a straw. You have to be able to see through it, but it's okay if it has a little color in it like this one does, rubbing alcohol, and finally you're going to need either clay or tape. It's easier with clay, but I'm going to show you how you can do it with tape in case you don't have clay with you. So you're going to start off by taking your plastic bottle, and if it had any sort of wrapping on it, you're going to want to remove that. But before you do that, take a look and see how much it held originally. So in this bottle holds 500 milliliters. And we're going to want to fill it halfway full. For this bottle, I would take 500 and divide that by 2 and get 250 milliliters total. And for this experiment, we're going to be adding both water and rubbing alcohol, and you'll want them to be at a 1-to-1 ratio, which means you'll want to add just as much water as you'll add rubbing alcohol. We're going to take that 250 milliliters for this bottle and divide it by 2 one more time. So that's going to give 125 milliliters of water and 125 milliliters of rubbing alcohol. So right here, I have my water already measured out, so I'm going to add that to my bottle to start off. You'll want to be careful when you're pouring so that you don't get it everywhere, but you can also use a funnel to make this easier. So now that that's added, I'm going to add my rubbing alcohol. Make sure that you have an adult's permission to use this and that you don't drink it. If you don't have something to measure out your liquids, you can also just take a look at the bottle, and you'll want to fill the water until it looks like it's about a quarter of the way full, and then fill it until it's halfway full with rubbing alcohol. So once you have that done, you'll want to swish them around a little bit to make sure that they're mixed, and then it's time to add your straw. So if you're doing this with clay, what you're going to do is you'll add the straw into your bottle, and you want to make sure that it's below the line of your liquids, but that it's not touching the bottom of your bottle. So at this point, if you're using clay, you'll just want to hold it in place and wrap the clay around the bottle so that it forms a seal around the top of your bottle. If you're using tape, I'll show you how to do that now. So I'm going to take the straw out, and first I'm going to take my tape and get a piece that's bigger than the size of the opening of your bottle, but just by a little bit. You don't have to make it too big. So I'm taking this square of tape and I'm going to put it over the top of my bottle. So the goal of this part, whether you're using tape or you're using clay, is that you're going to want to make a seal with the top of your bottle. The way that this thermometer works is that the liquids that are inside, when they're heated up or cooled down, they're going to want to expand or contract, which means they're going to want to get bigger or smaller. And if you have a seal on the top of the bottle, the only place that liquid is going to be able to move is up the straw. And that way you'll be able to see the liquid move up and down the straw, and you'll be able to tell whether it's getting hotter or colder. While you're doing this part, an easy way to tell if you have the seal properly done is if you squeeze the bottle, you can hear whether or not there's air coming out. And if you hear that sound, you'll want to add a little bit more tape, or if you're using clay, you'll want to place the clay a little bit more carefully. Make sure that when you're placing the tape, you really smooth it down carefully because you want to have no room for air to get around. So once you have this part done, it's time to add the straw. So what I'm going to do is I'm going to take a pair of scissors and poke a small hole in the top of the tape. You might want to get an adult to help you with this if you're not comfortable doing it. And then once you have that little hole poked, you're going to make it a little bit bigger just by pushing it until it's big enough for you to just fit your straw through. You'll want to make sure that this hole is big enough that it's not squeezing your straw shut, because you want things to still be able to move within the straw. So once that's big enough, you'll just put your straw through and make sure that it's not touching the bottom of your bottle. Once that's set, there's still going to be room around the straw where air is able to move, and you'll want to cover that up with tape. So once again, like you did in the beginning, you're going to be taking tape and sealing around this straw. A way to check at this point if your seal is made properly is that you can cover the top with your thumb or a finger and squeeze the bottle. And if you can hear air coming out, you know that you have to work a little bit harder to get that seal. So once you have this done, it's time to test it. One way to do that is to take a bowl of warm water and put your thermometer in, and you can watch the liquid inside moving up. You can also take it and put it inside a fridge or take it outside on a cold day and you can watch it go down. There's part 1 of our weather station made. Next up in our weather station, we're going to be building an anemometer. Anemometers work to measure wind speed. They can be built a lot of different ways, but the ones that we're going to be using is going to be measured using the angle of something being pushed by the wind. To make this, you're going to need tape, a ruler, something to write with, string, a pair of scissors, cardboard, a protractor, which is a tool used to measure angles, and a ping pong ball. But if you don't have a ping pong ball, just make sure you're using something of a similar shape and weight. So to start off, we're going to be using the protractor. So protractors are used to measure angles. As you can see here, it has a lot of different lines that you're going to be using to measure these angles. What we're going to be doing with this is we're going to be extending it onto this piece of cardboard so that it's easier to read when you're outside measuring the wind. So the first thing you'll want to do with this is line up the bottom black line with the bottom of your cardboard. Make sure you have a straight line on your cardboard and that it's lined up with this black line. Next, you're going to be making markings at different angles on the protractor. So you'll want to make a mark at 90, at 75, at 60, at 45, and at 30. On the other side of 90, you're going to want to make measurements at 105, 120, 135, and 150. Once you have your dots made, it'll look like this. Now what you're going to do is you're going to take your ruler and you're going to connect those dots outwards and to the bottom of your cardboard. Once you have all of these lines made, it'll look something like this. So you'll want to make sure to be really careful that you're lining them all up together at the bottom of your cardboard. Once you have those lines finished, it'll look like this. You can see here that all of these angles look similar, and that's because you're skip counting down by 15 as you go through the angles. Now taking another marker, or anything else, you can use the same color if you want to. We're going to add in the measurements for how fast the wind is going if something is being pushed to that angle. For these wind speeds, you're going to write in 0 meters per second at 90 degrees, 4.5 meters per second at 75 degrees and at 105 degrees, 6.6 meters per second at 60 degrees and at 120 degrees, 8.7 meters per second at 45 degrees and at 135 degrees, and 11.5 meters per second at 30 degrees and at 150 degrees. Once you have that done, you're going to take your scissors and cut a very small line right where all of those meet. It's just going to be a little bit there so that your string can fit in later. Now you're going to take your string and attach it to your ball. Make it secure enough so that you can hold up the ball with the string and it won't be falling. Now with that hole that we cut in the cardboard earlier, you're going to take your string and fit it right inside there so that it's secure and it doesn't move around. Next up, you're going to take the ruler that you have and measure the string to make sure that there's 30 centimeters between the point where it leaves the ball and the point where it hangs at the top of your protractor. Since we haven't secured it on the protractor yet, it's going to be easy to move around to make sure that it's the right measurement. So mine's a little bit long, but I can just pull it from the back and it'll shorten up. You want to make sure that it's as close to 30 centimeters as you can get it, so that the measurements we have written for the speed of the wind are accurate. Once you have that at 30 centimeters, you're going to take another piece of tape and secure the string on the back of your protractor. And you'll want to just tape it down right behind the slit that you cut earlier. And then you can cut off any extra string that's hanging off the back. Once that's done, you have finished constructing your anemometer and you can go outside and test it. When you're outside with this in the wind, it'll push your ping pong ball and you'll be able to look and see what angle it's being pushed to, and based off of that, you'll know how fast the wind is going. For the last part of our weather station, we're going to be making a rain gauge. Rain gauges are used to collect falling water and measure how much rain has fallen. To make one of these, you're going to need a 2-liter plastic bottle, a ruler, something to write with, tape, scissors, water, and something to weigh down your rain gauge. I'm using beach glass, but you can use rocks, pebbles, marbles, sand, anything you have around. The first step in making your rain gauge is to take your 2-liter bottle and cut the top off of it. This is a little bit tricky, so if you're having trouble, you can ask an adult to help you by poking a little hole in it with a sharp pair of scissors or a knife to get you started. Once you have the top of your bottle off, it should look something like this. Now is the time when you're going to add the weight into the bottom of this part of your bottle. So you're just going to want to carefully pour it in like this. And this is just so that you have something sitting in the bottom so that it's harder to tip over. As you can see with mine, whatever you put in there, there's going to be gaps in between, and that means that when the rain falls, it's not going to accurately measure. So what we're going to do is add in some water to fill in those gaps so any rain that's collected will rise above that evenly. The water will also help in weighing down your bottle. Once you have that set, you're going to take a marker and mark where that water is. And that's going to be your 0 point for your rain gauge. At this point, you're going to take your ruler and you're going to line it up with that 0 point and you're going to make a mark at every centimeter going up the ruler. Once that's done, it should look something like this. If your marker doesn't easily write on the plastic, you can take a piece of masking tape and put it on to write easier. Now you're going to write up numbers starting from 0 at your bottom line for all of the marks on your bottle. Once you've finished putting markings on each centimeter of your bottle, you've got the measurement part of your rain gauge completed. Now, you're going to take the top of the bottle that you cut off earlier, and you're going to place it inside like this. This is going to act like a funnel for the rain that's coming in. Once that's set, you're going to take some tape and tape it around to secure it. Once that's secured, you've completed your rain gauge. You can put it outside and measure the amount of rainfall. One thing this is useful for is if you have plants outside, you can tell how much water they're getting from the rain. After your rain gauge is done, your weather station is officially complete. You have a thermometer, an anemometer, and a rain gauge to help you measure the changes in the weather. Try keeping a weather log to keep track of the conditions and how they change. Have fun!
And here's Gracie with a cool experiment you can try.
Hi everyone, Gracie here again. Spring is here and this means that some days are super sunny and some are still really cold. Ever wonder how the weather can change from day to day like that? Well, there are lots of factors that influence this. One of the main ones is a process called convection. Convection is where air or any gas or liquid starts to move around in a circular pattern. This happens when pockets of air get warmer. We see this, for example, in the morning when the sun comes up and warms up the ground, which can also make the air close to the ground warm up too. These warmer air particles start to move around a lot quicker and need more space. This makes the warm air less dense than the cooler air above it. So, the warm air will start to rise into the atmosphere. The circular pattern of air moving happens because when the warmer air rises, the colder air falls to take its place. As long as there is a difference in temperature, this will continue to happen. We learn about what all this means in weather. Let's explore an example of convection we may be more familiar with. A boiling pot of water. When water boils, hot water in the bottom of the pot rises to the top, making bubbles and sometimes steam. It's the same with convection in the air. I've prepared an experiment that shows us how all this works. For this activity, we will need a large clear container, a small clear jar, cold and warm water, some food coloring, and some string. Okay, so this is going to be very, very warm, so you're going to have to do it very, very, very carefully. It's not going in. It's floating. You might need help from a parent.
The strings.
Ah. Notice how the hot water is starting to rise to the top already, and the clear water stays on the bottom. This is what we call convection. If you leave it, it'll all become the same color because it will become the same temperature. So if you've ever played with water beads, then you know that they will sink to the bottom. I was curious to know that if it was filled with hot water, would they float or would they sink? So these ones have been soaking in hot water, so I wanted to see what would happen. They're going to the top. Even the ones that were in the cold water, well, some of them are falling. The longer you soak them, the longer they'll stay up, probably. That's pretty cool. What's really neat about convection in nature is how different types of land like sand, rocks, and roads heat faster than others, like forests, rivers, and lakes. This will make pockets of air that warm faster than others. The faster moving pockets create what we call thermals that can carry moisture up into the sky. Because air is moving in different ways and at different speeds, different types of weather can start to form. Convection can form clouds, cause it to start raining, and change the wind. Understanding how convection works and how it affects the movement of air really helps us understand how weather changes and why. The next time you are outside, take some time and observe the different types of convection going on around you. Stay brilliant!
This simple water purifier uses the water cycle to create safe drinking water. The sun causes the water to evaporate, but it leaves the salt behind.
"12 seconds later."
The pure water is caught by the plastic like it would be by the atmosphere. It clouds up, and when enough of the drops get together, they fall just like rain. The stone in the middle of the plastic is just to weigh it down and direct the drops into the container in the middle. I learned this method when I was in grade 5. We were learning emergency survival skills.
Two hours later. Six hours later. Eventually, the next morning, the next morning,
This was a very small experiment, so it did take a couple of days to get just half a cup of pure water. I hope you try this at home. It's really neat to watch the progress. That's all for today. I learned so much about the weather and how we can try to predict it. I hope you try some MakerFun yourself. If you want to share it with us, you can find us on our social media or our website, brilliantlabs.ca. I want to thank these awesome special guests for joining us today. And I want to thank these folks for helping out behind the scenes. Stay brilliant. We'll see you next time.